So then we get 2 times 3, which is 6, 2 times 5, which is 10, 2 times 7, which is 14. So our constant, in order to take our rate of change and make it into our output number, we'd be adding 2 each time. So now we get 8, 12, and 16. So our full equation is the tops of the 3 columns. The perimeter equals 2n plus 2. Good. Okay, so if you'd have thought that the perimeter of 20 squares would be 42 centimeters, verify, underline that. Verify means to check. So you take your equation and write it out. Then you substitute in the values. So the perimeter is 42. That's what she thinks. And then the number of squares, n, would equal 20. So in red, I'd substitute in 42 and 20 for n. And the rest of the equation stays the same. So 42 equals 2 times 20 plus 2. Great wall of check. Then you get 40 plus 2, 42. Left side equals right side. It's verified. Okay, I need to see the bed mass. After you substitute in, you're doing bed mass. And I need to see the bed mass. Okay. Any questions? Okay, so now we're getting a little trickier. Okay. So now what we have is we have our perimeter and our rate of change. Okay. But what we have is that each toothpick is 2 centimeters. So once you count the squares, you got to make sure you're counting by 2. So you're not counting the squares, you're counting the outside dimensions. So these are toothpicks. Count the number of toothpicks. There's 3 in the first triangle. But the perimeter would be 3 times 2, so the perimeter is 6 centimeters. Right? Each toothpick is 2 centimeters. Right? So right here, each toothpick is 2 centimeters. Go ahead, fill out the table, make the find the equation.
Triangles?
Right? I gotta read myself, don't I? Triangle 1. Thanks, guys, for being so persistent. So this would be triangle 1. There you go. So 2 triangles, 3 triangles. What's the perimeter? 8 and 10. So rate of change is 2 over 1. So 2, 2, 4, 6, plus 4.
Yeah.
And so the perimeter equals 2n plus 4. Hence, if you got that, good. So then you went ahead and answered the next one. Did you? Good. What did you find? It's not correct. Good. And I just erased it. Okay. So real quick, she substitutes in 26 equals 2 times 10 plus 4. Great wall of check. 20 plus 4, 24. So she is not correct. Okay. Good. Any questions? Yep. Me too. Oh, the constant would be plus 4. I just didn't write it out, sorry. So 2 plus 4 is 6, 4 plus 4 is 8, 6 plus 4 is 10. Okay? Good. Any other questions? Okay, continue on with the next one. Go ahead. Oh, whoops. I see what's going on here. Okay, so now we're solving it from a word problem. So not only should you be able to solve it from, there's 2 things you should be able to do. Number 1, if you have diagrams and stuff, you got to fill out your table. Number 2, if you have a word problem, you can come up with your equation. If I just give you the chart, you should come up with an equation. If I give you points, Then you put it into a chart and you come up with the equation. Okay, so there's different ways of doing this. So here we have $12 a t-shirt. Okay, Time Stand Still wants to make $12 a t-shirt. This is going to be repeating, right? So it's the cost. So it's going to be 12 times every t-shirt. You do that when you go in the candy store. You buy 5 gumballs at 10 cents and it costs? Exactly. What did you do? Cost times the quantity. You do that all the time. It doesn't change for word problems. Okay? So it's cost times the quantity. Okay? We just didn't know the quantity. So for us, we have to use the letter T for our quantity. But there's a setup charge of $75. Okay? This is your constant. It doesn't change. If he doesn't buy any t-shirts, but how much does he have to pay? $75, because he had their graphic designers make something. Okay, so the equation would be the cost equals 12 times the number of t-shirts plus the $75 charge to set everything up. Okay, and so C would equal cost. We would try and make our letters for word problems, make them represent what we're talking about. Okay, it makes it a little easier. Any questions with number 5? Okay, so this is kind of repeating our word problems unit with a slightly different take on it. Good. We could go and graph that. We'll do that later. What we're going to do now is make an equation. So go ahead, find your rate of change. Tell me what you're going up by. Oh, that's weird, eh? What are you going up by here for y? We're going up by -10. Get it? -10 going down. So it's -10, -10. Okay. Go for it. Try and find your rate of change. I'll give you a second. So this is 14 and 14. So your rate of change is -10 over 14. Lowest terms, -2 over 7. Now we do this multiplication all the time. We've done it before, the canceling stuff. Yeah, that's what I said. I'm not sure why you chose 2, Ethan. Jeez. Must be for that basketball game last night. Okay, so we multiply that by our input of x. So we get -5 over 7 times -7. -5 over 7 times 7. -5 over 7 times 21. Make sure you cancel first, please, before you go and... okay, so cancel first. 7 and -7, what do they cancel to? -1. So this equals +5. Right? You have to be able to multiply a fraction by a whole number. It's a huge, important skill. These two to cancel to +1, and we get -5. These cancel to +3, -15. So what's your constant then? -3. Okay, so let's double check that by filling out the chart. -3 equals 2, -3 equals -8, -3 equals -15. So your equation is y equals, oh yep, thank you, -5 over 7 times x. Make sure x is not written in the denominator. That's absolutely wrong. Right, Noel? What's wrong? What shouldn't you do, Noel? No? Well, that too, but, yep. Yeah, x should be in the middle, or x should be at the top. But it should never, ever be in the bottom. If you're writing these sideways fractions, stop doing it right now, because I'll mark every one of them wrong. Okay, this is showing that you actually have -5 divided by 7x. Okay, so these things are wrong. Okay, watch out for those sideways fractions. I wouldn't write them. Dangerous, scary. Okay. Any questions? Thank you guys. Okay, so real quickly, we're going to use the table of values to make an equation, which is the dependent and independent variable. So the dependent is our x, sorry, our y, and our independent is our x. So if we're doing little axes here, this will be our independent, and this will be our dependent. This is usually what we measure, right? So we measure temperature, right? We don't really measure time, we just record it, right? The clock measures time for us. So this is going to be your independent variable. So we can say blank depends on blank. So this would be our y depends on x, the independent, right? So come up here with an equation, please, real quick. You need to make your chart with your columns, please. Go ahead, make an equation. It will be a fractional slope. Okay, go for it.
Y equals 3x plus 4.
So it's 4. What is this, 13 and 25? Where are you going up by there? 12? Okay, so it's going to be 12 over 3, which is 4. So we give 4x, which is 4 times 3, which is 12. And our constant will be plus 1. Right. 3x. Let me erase those lines. Okay, so rate of change, ROC. 12 over 4, which is 3, so 3x. 3 times 3 is 9. 9 plus what? Plus 4, 13. Okay, so your equation is y equals 3x plus 4. Hands up if you got that. Okay, good. I didn't fill out my chart just because of time-wise, okay? Try this one. Now it's going to be a little bit harder, okay? Find your rate of change. Don't cheat like I just did. I did that because of time. You guys take your time, please. You need this practice. Properly do your rate of change and your constant. Okay, so let's continue then. So we have discrete data, which involves whole numbers of objects. Don't connect the dots. So if you're going to Superstore and buy jugs of milk, you only buy 1, 2, 3, 4. You don't buy 1.5 jugs. Superstore would not like it if you cut their jug of milk in half, left half on the floor, and took the other half to the till. Wouldn't be too cool. Number of people, whole numbers. You don't cut a person in half and graph half the data, right? It's either a whole person or not a whole person, okay? Continuous data, it's reasonable to have points in between and past plotted points. Okay, so for example, measuring in meters. It makes sense to have points above and below 1 and 2, right? 1.1, 1.2, etc. Money as well, you can have change, okay? So, Having continuous data allows us to interpolate and extrapolate using graphs. Interpolate will be find values in between. Extrapolate will find plot points after. So this is an example of interpolating. Do you have a slip of paper? You need to go to the office, sign it. Oh, good. I just need a slip of paper. Good, thanks. And the notes are right behind you. This is an example of extrapolating. So for extrapolating, you have to draw this extended line first. Good. Okay. All right, so here's a graph of a plane landing. The plane starts 20 kilometers in the air, and it's slowly descending to the ground. Now, what was the plane's approximate altitude at 50 seconds? So approximately here is 50 seconds. Use your ruler, draw a line straight up, and then use your ruler and draw a line straight over. Now this question is totally cooked up, isn't it? So you can see that it's 10 kilometers. Now usually it's best if those are dashed lines, okay, because you don't want to get it mistaken with the graph, so it is best if it's dashed. I don't think I can draw dashed though. No. Okay, so then next question. What was the plane's altitude across at 11 kilometers? So now I start on the other axes. I started whereabouts it is at 11 kilometers. I go over to my line and then down, and it's approximately 40 seconds. So it's approximately 40 seconds. Now I could have put 41 or 42, and I take that as a correct answer. Good. Is it appropriate to join the points with a straight line? Explain. Yes. It's continuous data. Right? So it makes sense to have points in between. How many people have been on a plane where it's instantaneously lowered 2 kilometers? No one? Good, because you'd be dead. Right? Planes gradually decrease to the ground, just to let you know. They don't instantaneously drop. Good. Any questions? Turn. Okay, go for it. So what we do now, though, is the data stops at 400, but we want to know more information. So what we have to do is we have to extend the line. So we take our ruler, put it on the line, and we just extend it down. Now I'll make it blue so you can see it. Okay, so that's the line extended. Okay. Now you can answer the questions. After what approximate, underline the word approximate, period of time does the computer have no value? And if I had done mine a little better, there you go. Yeah, it should be 5 years. Okay. When was the computer worth approximately $200? So use your ruler, draw a line over, so you touch your graph, and then down. And I'd say approximately 4 or even 3.9 years. Okay, but most of you are probably going to put 4, and that's fine. It's approximate, right? Is it appropriate to join the point to the straight line? Well, you're measuring value and years. So I'd say yes, continuous data. Any questions? Okay, so what we're going to do now is we're going to do our graphing. When you're graphing, you need to have a table of values, which we have at the bottom. Okay. Then what we can do is label the X and Y axis and include units. Now this one's a bit of a special graph because our altitude, so the temperature, depends on altitude. That's not right. How can it make sense? Yes, that does right. Sorry. Temperature depends on altitude. Yeah, I never like this one because it's not as clear cut. Okay. So this is our Y variable and this is our X variable. Now for temperature we have some negative values. Okay. So that means for our Y we're going to have something like this. This is probably the most difficult graph you'll face. I'd put it about there. Okay, and then you should just extend the bottom. Okay, there you go. Again, this is quite a difficult graph to draw. So, you gotta get it down to minus 10. I'd count by 2's. So, minus 2, minus 4, minus 6, minus 8. Here's negative 10. And then count up by 2's. 2, 4, 6, 8, positive 10. 2, 4, 6, 8, 20. Okay. So what you could do is you could count your total values and divide by the number of squares. So for example, for the altitude, 1800 is my total value, and I can count the squares. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So I divide by 31 squares, grab my calculator. So I have to go up by at least 58 a square, but to make it easier, I'm going to go up by 100. Okay. I can't go smaller than 58. 60 is kind of weird. 75, okay, but still hard numbers. Make it easier for yourself. Go up by hundreds. So 100, 200, 300, 400, 500. Don't label every line. 6, 7, 8, 9, 1,000. 1, 2, 3, 4, 1,500. 1, 2, 3, 4, 2,000. 5. Okay. So now I have that decided, then I plot my points. So the altitude's 350. So I'll be between 3 and 400. The temperature is 11.4 degrees. So my first point, I'm looking to be right here. Now don't put that big circle around it, I just want to show you where it was. It's not on a grid corner. Okay, I have to estimate my x's in between 300 and 400, and then estimate my y values, 11.4. Pretty close to, getting close to 12. Okay. Okay, plot the next ones, go. Okay, here's your next one. 750 is between 700 and 800, and 5.7 is getting close to 6. Then the third one should be just above the line. Okay, just above the 2, on, but exactly on the 1,000 line. Okay, the 1,500 should be right there. Okay, right in the middle. So that's where -5 would be. 1,800, -10. Okay. Now, if you do this, you should be able to make a straight line. Okay. And we're pretty close, which is good enough for me. Make it a little thicker, and yes, it goes through my points. Aha. Cheated. Okay. Okay. Any questions? Okay, you do homework. It's listed on your outline. You have 4 graphs to make. Okay. If you have graphing paper, please use it. If not, I will provide some. Here's some graphing paper. If you need some, just hole punch it.